In the last phase of the cardiac cycle, we're going to move back into ventricle relaxation. And as with building up of force, we're also going to take an additional time to relax that force, to decrease that force. But the calcium that's found in the cardiac muscle will be put away, and the muscle begins to relax. Once the ventricle, if we come back over here and take a look, once the pressure in the ventricle drops below the pressure in the arteries, then we're going to again see these valves slam shut. And at this point, then my pressure in the arteries, but we've shoved in some extra blood, so now we're probably at a higher pressure than that 100, so let's just go ahead and say 120 millimeters of mercury, just as an example. The pressure in the ventricle is probably still quite high, so I'm going to go ahead and say, let's say 119 millimeters of mercury as being that moment when those valves slam shut. So when the aortic valves on the left side of the heart or the pulmonary valves on the right side of the heart slam closed. And in that case, what we're going to notice is the pressure in the arteries is greater than the pressure in the ventricles. But 119 is still a lot bigger than, what did we decide the atria was? I think I decided it was what 2.5 millimeters of mercury. And again, remember, that's not an exact number. That's me picking a number that's around the right-ish number, but not exactly the right-ish number. I don't actually know what the pressure is for sure. But you'll notice a big difference between 119 versus 2.5. And so the pressure in the ventricle, we probably actually even should do this because it's substantially greater than the pressure in the atrium. But that pressure, that 119 pressure, is going to rapidly decrease. So pressure rapidly decreases at this stage. So by the time we're at the end of this stage, we're going to go from 119 to the moment that the valves open, the mitral valves open, so we would have to be 2.4 millimeters of mercury, a little bit less than those mitral valves, or even to 0 as we begin to relax, in which case the mitral valves would then open. But while both of these valves are closed, blood's not going anywhere, so we're not surprisingly back into an isovolumetric stage. And we call this isovolumetric relaxation to reflect the fact that the ventricle is back in diastole. It's now relaxing, the force is dissipating, and we're relaxed. Note that the atrium is in diastole too, so while it's not shown here, blood would be flowing into the atria at this point. And so the pressure in the atria is essentially going to be building from, let's say, 0 to 2.5 as we get this buildup of the pressure there. Now, when we have an isovolumetric phase, I want you to flip back up here and take a look. In the isovolumetric contraction phase, we had what we called the end diastolic volume, which is our max volume that the ventricle, the volume in here, the maximum that we were going to see, or the maximum that we could have during one cardiac cycle. And likewise, here we have another isovolumetric phase. And so if we were to look at the blood volume here, trapped in this little chamber right here, nowhere to go, it's stuck. Both doors are shut. If we look at that, we call this the end systolic volume, and it's the minimum volume during one cardiac contraction cycle. Now again, we're going to get some fluctuations in that end systolic volume. One value I have seen is about 65 milliliters. So there's always some leftover. Now that number will change. If the heart is working harder than normal, we might have a smaller end systolic volume. If we're maybe sleeping, we might have a larger. It acts as a bit of a reserve volume in that we can manipulate this volume to eject more or less blood. But regardless, this is the leftover volume, the minimum volume that occurs during that one contraction relaxation cycle. We're going to talk a lot about end systolic volume and end diastolic volume when it comes to regulating something called cardiac output, which is the amount of blood that the heart moves out of the heart into the arteries in a period of 1 minute. The pressure for this is going to gradually decrease. So as we're in this isovolumetric contraction, as I mentioned, we're going to gradually decrease. And the moment the pressure is lower than the atrium, we're going to exit isovolumetric contraction, and we're going to go all the way back here to our rapid ventricular phase, also known as passive filling. The valves will now open here, and we will begin to add blood to the ventricle. And we now repeat this cycle. We're now in another cardiac cycle. We're repeating another one. And that will continue for the life cycle of the heart, for the entire life of the heart, for as long as you are living. And that really wraps up the cardiac cycle. We're going to next look at the cardiac cycle as it is related to something known as the Wigger's diagram. Here's the Wigger's diagram. I'll take you through that in the next video.